Okay, camera check, 1, 2, 3, let's move that out a little bit. That's all lined up nicely. Yep. Yeah, seems to be alright. Move that over a little bit. There we go. Yo, how's it going, Matt? Matthew? What do you prefer to be called, by the way? Matt or Matthew? Just out of interest. You can move me over a little bit. There we go. Happy Christmas, Steve. How's it going? Blake, what's up? What's up, Synthetics? Thanks for jumping on the old Christmas stream. So a couple of years ago I did Streammas, which was a live stream every single day leading up to Christmas. Definitely can't do that this year. It was really hard. It was really hard work doing that. But I thought I'd just maybe try and squeeze in a couple of live streams before Christmas sets in. Matty. Who calls you Matty? So on the bench for the first thing we're going to be looking at this evening on the bench is going to be this. This is a B2 Audio Riot 3200, which is just the Chinese clone of the Sound Digital circuit. So very generic circuit board. I'm very experienced in these. Done loads and loads of work with these over the last few years. A couple of family members. Maybe that's kind of like stuck from when you were younger, perhaps. This screwdriver, I quite like it. Has a good feel, good grip. But the worst thing about it is that it's a lack of magnetism. It just doesn't, the magnetism on the tips just doesn't work with it. I don't know if it's just due to the magnet in the driver or the bits or whatever, but yeah, it absolutely sucks. I don't like this driver as much, but it is much more magnetic. You know what I was actually considering asking for Christmas was the LTT screwdriver, just because of all the hype around it, and it's a kind of good Christmas gift thing. But the problem is the shipping to the UK is really expensive, and I don't want to pay that much for a screwdriver, and I don't want anyone else to pay that much for a screwdriver for me either. So, but I feel like a ratcheting screwdriver would actually do me good. George says, "Hey everyone, new to the group, awesome channel, thanks for your help, you didn't know you gave me." Ah, nice one, George. Thanks for jumping on the stream. I'm glad that you are finding this information useful and entertaining in some way. See, I much prefer this one. It's much better, but it's just not magnetic. I class the LTT screwdriver as a really high-end screwdriver. Did you see Project Farm's comparison, including some much more expensive ones? It's actually pretty good for the money. Yeah, you can get close to its performance for a bit less money, but it is actually pretty good. Love the EV video you made. Lots of misconceptions out there. Thanks, Blake. Appreciate that. Yeah, man. There's lots and lots of misinformation, and honestly, like going around Facebook and stuff, like, you know, on all the audio forums and stuff like that, so much misinformation gets spread just because it's kind of regurgitated, and you know, it's kind of information or stuff that people have just kind of dragged with them, and it gets regurgitated on the forums like over and over and over again, that people just believe it as gospel. And it's really tricky. Like when I know, when I know the correct how to put this, when I know for a fact, due to like legitimate evidence an experience I've had on something, when I know for a fact that a commonly thought fact is actually incorrect, but so many people stand true to it and believe it and will swear by it on all of the forums and groups, if I try and come in there and say, well, actually, that's not actually true, and this is how it is, and it's how, and it's like this because of this and this reason, and you know, all this actual hard evidence as to why that this thing that people think actually isn't true. Honestly, people don't like hearing that. So I found myself these days just generally trying not to comment on social media, on any of the audio groups about all sorts of things. Sometimes I can't help myself. Sometimes I'll type out a long comment and I'll be like, nah, this, like, people aren't going to understand this. People are going to think, no, that's not how it works. Yeah, it works like this because that's the way my mate told me, that's the way his mate told me and his mate told me. So then I'll just delete the comment. I just like backspace and don't bother commenting. But it is really hard. So much misinformation gets spread around the forums. But yeah, with the EV thing, like that was one of them. I kept seeing comments on posts about EVs as, you know, oh, this will affect your range of the EV, and so I wanted to make a video about it, and it kind of explained why that's not the case. And I still have comments on that video of people not understanding the thing that people can't understand is people can't understand how the alternator sucks fuel from the engine, like how having your alternator loaded and dropping a bass tone causes the engine to like have to work harder to turn the alternator. People can't seem to grasp that concept, and the reason people can't grasp it is because there is a massive disconnect between the energy types, and people aren't seeing the kind of fuel and the rotation of the engine as kinetic energy being transferred into electrical energy. There's a lot of disconnect between how that conversion happens, and also a disconnect between there's a lack of understanding of how alternators work, in that when they're loaded, when you actually demand current from them, that they tense up and they're actually harder to spin. People don't realize that. So there is this massive kind of disconnect between electrical power from the alternator and where that actually gets that from. Some people think that a 300 amp alternator is always creating 300 amps, or people think that the alternator just kind of spins freely and just creates that power regardless and doesn't change. Or it's an interesting one, and even after trying to explain it, it's very difficult for some people to actually understand. Alright, what have we got here then? So we have, this is actually backwards. This is interesting. This is the opposite way around to normal. So this is the BT Audio Riot, which is a Chinese clone of the Sound Digital circuit. Very, very generic circuit design nowadays. I've worked on these hundreds of times. Now usually when an amplifier fails, okay, if the output MOSFETs fail, then they will look visibly fine because they just short, and then they create a short circuit environment that the power supply then dumps its current into and overloads, and then you have the power supply FETs burn out because they are fed with constant current, whereas the output FETs, as soon as they die, the voltage just dissipates and they don't really get cooked by much. So usually you have power supply FETs that are visibly burnt and black, and output FETs which look visibly fine. However, in this case, it's actually backwards. We have output FETs that are all burnt and crispy and cracked, but the power supply FETs look absolutely fine. Now when this happens, it's usually because the short circuit inside the output MOSFETs that happened was a high enough resistance that it didn't cause the power supply FETs to overload, and it didn't trigger any kind of overcurrent protection. I don't actually think these amps have overcurrent protection on the power supply side. There is no way for the power supply section to detect overcurrent as far as I'm aware. So if the output MOSFETs short in such a way that the short is a relatively high resistance short, then the power supply FETs will just work their asses off, dumping as much current as they can into that short circuit environment over on the output FETs. Now this circuit should protect from a DC offset, the difference at the speaker terminals, or actually even when there's no class D switching it should protect. So not entirely sure how that's managed to happen, how we've got such a burnt output MOSFET here, because for that to happen, this will have had to been shorted and the power supply will have been still running. So yeah, maybe the exact circumstances around this failure were such that the protection circuit didn't kick in. For whatever reason, the amplifier didn't detect it as an issue. So in the output section, because it's a full bridge amplifier, we have 2 FETs here running one channel, if you like, one half of the bridge, another 2 FETs running the other channel, and you've got 2 inductors here, one for each channel. So these two, let's have a look at these. Are these shorted? So this channel is absolutely fine. The channel of the FETs that failed were obviously these two. So they can go. First and foremost, they can be cut out of the board. With a full bridge amplifier, you've essentially got 2 amplifiers sharing the same PCB and sharing the same power supply. So the fact that this amplifier failed doesn't necessarily mean it's affected this one in any way, or this drive circuit, because this is a completely separate amplifier just sharing the same PCB. So provided the drive circuit of this one didn't fail in such a way that it spiked back through the VCC line and killed this chip, then this amplifier will technically be absolutely fine. Although because it's only 4 FETs, you might as well replace all 4 FETs for new while you're here anyway. It doesn't really add much time or add a great deal of cost or anything like that. So let's see then, just to confirm, did the power supply FETs actually survive? Yeah, got no power supply short whatsoever. Yep, there we go, charging the power supply filter caps. So this short was a high enough resistance that it didn't kill the power supply FETs. Sometimes in these amps the rectifiers get hit, which is very uncommon in Koreans. Oh, they did in this instance. The rectifiers actually shorted as well. So in this failure event, we have shorted output FETs, which will then demand high current through the rectifiers, through the transformers from the power supply FETs. And in most amplifiers, the rectifiers are actually the strongest link. The rectifiers rarely ever fail, even when you've got a complete total amplifier meltdown with all the output FETs shorted, all the power supply FETs shorted, and everything is dead. The one thing that remains, that survives, is the rectifiers. They very rarely die. However, in these amps, we only have 2 rectifiers for a 3200 watt amplifier. If you look at a Korean amplifier, you'll find that for a 3K, 3.5K amplifier, you'll have much more parallel rectifiers for that amount of power. So the thing that's different between these is this is a full bridge amplifier, so the voltage is lower, but the amount of rectifiers really wouldn't change that much. So these rectifiers in these amps are worked much harder than they are in Koreans. And as a result of that, they were the next thing to die in the chain. So we've got that one as toasted, and that one is toasted. Both these rectifiers are toast. Okay, cool. So let's go ahead and chop them those out as well, I think. S2 and S1, and these are labelled. The labelling is weird on these. They're obviously remarked parts. These are actually labelled as 1640. Now 1640, if you search that, that will be like, you come across like MURS 1620, which is a genuine part, for example. Lots of things like similar to that, and that means that it's a 16 amp 200 volt part, for example, would be the MURS 1620. Now this here suggests that this is an MURS 1640 or something similar to that, with a similar prefix. But the 1640, as far as I can see, doesn't really exist online. You can't find any datasheets for a 16 amp 400 volt rectifier that has that in its name. So either this is to send people off of the scent if people are looking to copy this for whatever reason, even though it's already been copied by China, so who else is going to copy it? As you can see, the output MOSFETs are remarked as well, H6, even though we know they're 4115s. So yeah, I think that this is just to kind of throw people off the scent if they're trying to find out what parts these are. But that won't affect us because we know what they are, and I've got loads of spares. Loads of 1620s, which are absolutely fine for this amplifier because the rail voltage is not over 200 volts. So we can shove that in there like that. Okay, so power supply is fine, so we shouldn't need to do any work on any of this section, We shouldn't need to work on the power supply driver over here. It's just going to be output sections business. So first thing we want to do is get the rectifiers replaced, and then we can start sending rail voltage into the output section, find out whether the drive circuit for any of these has survived. I'm also going to remove these H6 FETs, I think, and load her up with a full set of brand new 4115s. So let's get the iron turned on and get these parts and legs out. Mark Jackie's having an amp fix inception, watching amps getting fixed while fixing amps. Yep. Bevis, I'm pretty sure you have two mics on. There's a weird effect, the super slight delay on one of them. I do have two mics on, but I did check before I started live streaming whether there was any delay between the two, and I actually calibrated a delay, so it's possible that delay has now shifted. So guys, if my voice is echoey or weird and delayed, oh yes, Elliot says I'm getting echoes on the audio. Okay, hang on a minute, I'll have to just change that. So I'm gonna change the delay of one of my mics. Maybe I can just turn one of my mics off. If I turn this mic off, does that still sound fine? So this is mic number 2 that you're currently listening to. And this is mic number 1 that you're currently listening to. So mic number 1 is on top of my head. Mic number 2 is out in front of me. So let me know which one sounds better. This is mic 2. And this is mic number 1. Whichever one sounds better, I'll probably just stick with the one mic, because it seems that the delay shifts while the stream is playing. So I can't calibrate a delay between the mics, and because it will shift. Mic 1 sounds better. So this is mic 1 that I'm currently on now. Okay, cool. I will stick with mic 1 then. That actually makes life a lot easier for me. Let me just go ahead and get rid of mic 2 from all of my sources. Mic 2, GPC, top board done. Hatcam, mic 2, GPC, scope, GPC, web, GPC. Okay, so this should now just be mic 1, 1, 1. Yeah, that's all good. Merry Christmas, guys. Merry Christmas, Lynn Dizzle. Thanks for jumping on. Neerish, how's it going, man? Good to see you on the stream. Hope you and your family are well, buddy. Beverage, get them to drive a few hundred miles with a big sound system on versus off. Yeah, you really do see the difference. Problem is, most people don't actually know how, like, the miles to the gallon that they get calibrated on a long drive. You know, there's too many factors involved, and the sound system is such a tiny one of them. The smoke did leave some skid marks, you're right, it was in a hurry. Hello, audio is bad, yeah, just fix that. By the way, Sam, what do you look for in amplifiers as far as sound quality is concerned? What makes one amp sound better than another? For subwoofer amplifiers, this is probably the #1 controversial thing that I definitely can't voice on any of the online forums, because people just have too many opinions about it that are based on nothing but what someone told them, or for reasons that don't actually concern that. Subwoofer amplifiers all sound the same. The thing that sounds different is the preamplifier filter in them, as far as what the slope gradient is like and where the low pass filter kind of sets in and stuff like that. And And the problem is between different amplifier brands and factories, specifically between Brazil and Korea, the way that the crossover filters are set up in the preamplifier is so different. People say Koreans sound deep and smooth versus Brazilians sounding like they're gutless or like a bit too punchy and don't have any lows, and that is just purely down to the preamplifier filter design differences and how people are used to using them. For subwoofer application, the frequencies are too low, and subwoofers are incapable of actually reproducing any details. They're too slow and sluggish, and they're not transparent enough to anything that would voice any difference between amplifier topologies in terms of the output section. So for subwoofer amplifiers, I literally just look for a few main things. Build quality, how likely is the thing going to vibrate itself to death, sensible choices within the circuit, parts that are used, switching frequencies that are used, how good the drive waves look around the circuit, what the protection circuits are like, how it fires up, all sorts of things like that that basically factor into reliability, and also obviously how much power the amplifier will make. But yeah, really for subwoofer amplifier, as long as it makes the power that you need and it is built in a way that is reliable, then it's going to be absolutely perfect, and they all sound the same if you know how to tune crossover filters. For full range amplifiers, obviously the thing is different. You just need to look at other channels that will show you differences in full range amplifiers. Things like channel separation is a big one, especially for imaging and stuff, getting a nice sharp image and getting a really good soundstage. Channel separation is a big thing, and cheap amplifiers really struggle with that. Obviously signal to noise ratio, THD percentage, and when you're listening full range, amplifiers do have a sound characteristic to them, and different amplifiers with different output section designs and different circuit designs will sound different to them, because full range, especially tweeters, are very transparent to the tiny differences between amplifier topology designs, whereas subwoofers are just not. Where can I find contact info? DDM2M2C needs work. You should just watch my video I did where I repaired a Digital Designs M4A. It'll probably be the same working method, just on a slightly smaller amplifier. Who is Kane? I don't know who Kane is. That's the nicest sounding mic of any of your streams. Are you fucking serious? So usually for my streams, I set up a pair of RTA mics, left and right by the workshop, which gives you not only my voice, but also gives you ambient noises around the workshop, like my soldering station, pumps and stuff, like the relays in my power supply, just ambient noises around the workshop while I'm working, because I think it makes it feel like you're there more. So they're actually really high quality RTA mics, and you will then be hearing exactly what you would hear if you were in the room. This is just the built-in mic for my webcam that you're listening to right now. But if that comes across better on stream, then maybe I'll continue using that. What kind of battery bank do you have in your system? Not a particularly good one. It's just 4 Stinger SP2150s. So not the biggest, the step down from their biggest, 2150s, and I've got 4 of them AGMs. I haven't got lithium or anything. When you repair, can you also make an upgrade? On these amps, not really. They're already kind of maxed out in terms of the components that are used. For me to upgrade this, I'd have to add additional MOSFETs and stuff along the heatsink, which is not really space for. These things are kind of maxed out in terms of like making any upgrades and stuff. Unless I went really crazy and did something like the audio pipe, but yeah, that's excessive. Why do we not see phase adjustment on full bridge amps? It's just kind of unnecessary. Honestly, no one that I know actually either knows what it does or uses it. Like 90% of the car audio community doesn't use it or know what it does. So it's not necessary. Also, one good thing about not having a phase adjustment circuit is the reason that some amplifiers from the same model series are out of phase with one another, which I showed in my video where I showed you how to wire up multiple subs, multiple amps without a scope. I showed that 2 identical ground zero amplifiers were actually not in phase with one another, so therefore you couldn't gain match them using a multimeter because they were actually out of phase with each other. The thing that makes them be out of phase is the phase adjustment circuit itself. So if you get rid of the phase adjustment circuit, then the amplifiers should all be in perfect phase with each other. Dr. Diner, yeah, I absolutely agree with this statement for the most part. Yeah, I honestly don't think that for the most part people can tell the difference between amplifiers, and if there is a difference between the sound that is really, really obvious, it's not the actual amplifier stage that's causing that. It's other factors like some kind of pre-applied EQ or filtering network or something like that that's not actually to do with the amplifier stage itself. Yes, the reason you'll find you've got more punchy bass, Louis, is because the PowerRush filters are far more wide open. So that's letting through much more higher bass frequencies than your EMF audio 12Ks will have done, because the crossover slope is much more shallow and it starts much higher up on the PowerRush. So if you want to get rid of that a little bit, and if you want it sounding more like your EMF audios, then you would just need to apply a low pass filter on the head unit or DSP or something else before the amplifier, like at 55 hertz, 12 or 24 dB roll off, and then it will sound more like the EMFs. Are computer power supplies similar to car amp PSUs but in reverse? I don't, maybe? I haven't ever really looked at a computer power supply, so I'm not sure. Gordon says, yup, bruv, you are English like me. Harry Kane, the footballer who missed the penalty for England, mate, I could not give any less shits about football. I could not care about football in the slightest. Have absolutely no fucks to give about football. So I have no idea who Kane is, sorry. Right, let's get these out. Sam's more of a baseball person. I'm not a sporty guy. I'm not a sporty guy whatsoever, my guys. What's up, Henrik? How's it going? If there was a sport on, I don't know, something technical, I would probably be into it. You know what? I used to love Robot Wars as a kid. I think in America, I think you do have Robot Wars in America, but I think it's BattleBots is more kind of the American thing. But fuck yeah, I used to fucking love Robot Wars, man. I don't know if you class that as a sport or not. So yeah, let's drop these working FETs out as well. I'll keep them as one side as spares for some project or something. Yeah, Blake, it is difficult. Like I say earlier, like when I'm scrolling through my Facebook with nothing better to do, and you know, there's like a long discussion thread on an audio forum, even on the sound quality groups. Like the sound quality groups are generally have a much higher level of bass knowledge and understanding, and generally are much better, nicer places to hang out than the bass heads on a budget, bass heads on a low budget kind of groups. I feel like they're a sort of nicer place to hang out, and you get better quality conversation and discussion on there. But even on there, and even with people that are, you know, considered to know what they talk about, don't really know what they're talking about some of the time, and it's very difficult to not try to share what your thoughts are and why you believe it is a certain way and why you think they're wrong, without just literally everyone else who believes the same thing that they do being like, man, what are you talking about? Shut up. So sometimes it's just easier not to say anything. Hello, bro, watching from Dubai. Always watching your vlogs, and I learned a lot from you, bro. Thanks very much, Andres. Appreciate you, man. How is it in Dubai right now? Every amplifier I put in my car sound low, no bass. I tried tons of different amplifiers. So the amplifier is not the problem there. The problem is going to be subwoofer positioning, subwoofer enclosure, or settings that you don't understand on the amplifier or head unit, or the fact that it's a new vehicle and you're taking the subwoofer output from the factory subwoofer output wires using a high level converter, or the door speakers, which are high pass, so you're not getting any bass to them anyway. Yeah, you got some other issues. Yeah, I've got a massive blister on my thumb. It's nasty. Well spotted. Okay, so that's all the output FETs and the rectifiers. I need to suck them the holes for the rectifiers as well. Then we can drop some new rectifiers in and we'll be away. Oh man, I can Taloco, I can actually imagine that performance car tuning is probably even worse in regards to misinformation just kind of being circled and just assumed to be correct. Thanks, my man David. Thank you very much, buddy. Hello from Grand Rapids, Michigan, and Merry Christmas. Merry Christmas to you too, buddy. Merry Christmas to you too. I'm feeling quite festive in my Zelda Christmas jumper. Woo! Is Scar Audio any good? They have some products which are absolutely fine for the money. Yeah, like the thing is, we don't get Scar Audio in the UK, so I can't like say, oh yeah, I've looked at this exact model amplifier from them and it has this good about it and this bad about it and this sub is this whatever. Like there aren't any Scar Audio dealers or distributors or anything in the UK, so it's not something I come across. But it's like not much of it has any R&D behind it. It's all kind of generic stuff, but I think most of it looks like it's built okay. I imagine a lot of the hate for Scar comes from the fact that it is or was reasonably priced, and when you have something that's very reasonably priced for the amount of power that it is or the expectations of what it is, you get lots of less experienced people buying it because it's cheaper and using it incorrectly or breaking it, and then that's how it gets a bad name. That's exactly why the Sony Explod subs have a bad rep. The pentagon hexagon shaped subs from like the 90s and 2000s. Yeah, the Sony Explods are actually a very capable entry-level driver. They actually have a really stout voice coil on them. They don't have a huge amount of excursion or X-Max. The motor's not particularly strong on them, but they are really well built and they take a hell of a beating, and the coil is actually very stout on them. They do sound absolutely fine. You can get very loud with them. The reason that they got so much hate was because they were kind of sold very cheaply, and they were shoved in sealed boxes on like 100 watts, and they just didn't really sound that great for that reason. And also everyone had them and everyone's mate had them and people used them incorrectly and stuff, so yeah, they never really sounded that great. But when you actually do put them on some really good power and you build a correct enclosure for them, they sound fine and they get really loud. Negativity for Scars because they undercut their dealers. Oh, okay, so shady business practices rather than because the equipment itself is particularly bad. I have a small 4-channel amp that has a tiny bit of alternator whine. So alternator whine is a really difficult one, and the main reason that you get alternator whine is because there are there is a differences between how the amplifiers in your setup are dealing with signal side ground. One of the biggest causes for alternator whine is if you're using two different amplifiers, for example a bass amplifier and a 4-channel amplifier. If the bass amplifier has the RCA ground connected through the board to main ground, but your 4-channel amplifier has the RCA ground floated, then because the two amplifiers you've got connected to your system and to the same head unit use a different method of dealing with the signal side ground, you'll end up with this massive feedback loop through the RCAs, and that noise will come through your door speakers. So the solution to that is to make both amplifiers utilize the same way of dealing with signal side ground. So there's two ways of doing this. You can either run a ground loop isolator in line with the bass amp, which will then cause the bass amp RCA side grounds to be floated along with the 4 channels, therefore removing the difference between the two amplifiers, which should solve it. Or you can connect up, you can make the 4 channels RCA side ground continuous with the main ground, and the simplest way of doing that is to run a wire from the speaker negative terminal on one of the channels, the left channel negative, to the ground terminal on the amplifier, which connects the output side ground to the main side ground on the 4-channel amplifier, and that should get rid of the noise as well. You know the trick that lots of people do where they tell you to run some wire around the back of your head unit? They say, oh yeah, just wrap some wire around the RCAs on the back of your head unit and connect it to the head unit chassis. That is exactly the same as running a wire from the speaker negative of the 4-channel to the power ground on the 4-channel amplifier. It's connecting the same two things together. So that does work as well. Obviously the best solution would just be to use amplifiers that both have the same method of dealing with signal side ground, but that is the most common issue, and that's why sometimes people will try lots of different amplifiers. They'll be like, oh, this amplifier gave me loads of alternator whine, but when I put my Pioneer one in, it's fine, because maybe the Pioneer one has the same way of dealing with signal side ground as whatever bass amp it is they're using, or vice versa. By the way, Sam, have you seen the new Rockford amp that's powered by DC offset from a head unit speaker outputs? I don't know about powered by. That's interesting. I know that amplifiers use the DC offset from the head unit speaker outputs as like a signal to turn on, like because yeah. So I know that many amplifiers that have an auto on will use the fact that there's DC offset on the high level inputs to turn on from, but in terms of being powered by, I can't see that being a good idea, because the DC offset that is on those wires doesn't have any guts behind it. It is a I think it's just a floating midpoint between the 0 volts and the 14 volt supply. I don't think it actually has any guts behind it, so I can't imagine that anything would actually use that DC offset and try and draw a current from it. That's going to end in disasters. I think it must be to do with the turn on. You can't draw any current from that DC offset. It doesn't have any current behind it. Right, so that's all the parts out. Let's grab some replacement rectifiers first. I think I've got some in one of my drawers back here, if I can remember where I put them. I really should get around to labeling these. Okay, here we have some MUR 1620s. Although, I don't think I trust these at all. So these parts are actually from a manufacturer. So one of the really cheap brands over here in the UK, Bassface, which I guess they're similar to, oh, what would I say they're similar to? I don't know, like Audio Bank or something like that. Just a really generic cheap brand. They had a bunch of parts that were sent over from the factory, and they were like, oh, we've got nothing to use these for. Here you go, Sam, have some spare parts. But I'm looking at these rectifiers now, which actually I got from them. These are the spare ones I got from them, and I'm not really liking the look of these too much. The reason I'm not liking the look of these too much, I don't know how much of it will come through on camera, is if I get that just right, see how the center portion of this is like matte, and then you've got these two strips on either side which are kind of glossy. That looks like it's been blasted and remarked, perhaps. You know what I mean? Like, doesn't look that legit. Looks a bit kind of sketchy, and the font on here isn't like really that deep or what I'm used to seeing. The other one does actually look a bit more legit. The font still looks a little bit sketchy, And we still have those strips on either side, but we do have the stamp in the middle there. I'm not sure I trust those. I do have some genuine ones in here, and I've got loads of donor amps actually that I can take from. Because rectifiers are very difficult to get hold of at the moment. Here we go. I've got some 1620Gs in another drawer, in another thing here. Where's my hat cam? There we go. This is my drawer of rectifiers, which I'm running a bit low on. We're slowly starting to get parts come back in stock now. We had massive part shortage for months and months and months last year, but parts are slowly but surely starting to come back in stock. Oh look, wow, I've got a doubler. That is rare to see. MUR 1620D. That is a pretty rare part to be able to buy these days. U1620RG, there we go. That actually, both of those, they should work. 1620G, 1620RG. Those, I know those are legit because I bought those from Farnell. Let's see if I've got one of these that doesn't have the legs cut. Okay, now it's a case of working out which one goes where. I could work this out by looking at the traces and stuff, but because we have a current limiter available, I'm literally just going to shove one in there and one in there, like so. Attach some power cables and limit the current supply to about 1 amp. Pulse the remote a couple of times and see if we get any rails built. If we don't, then I'll just swap them around. When I switch to a DLS high-end amp, it's gone. Is the amp broken? Henrik, you were using, but I only have 1 amp. Oh, if you only have 1 amp, then yeah, that doesn't sound great. It could be that there is some damage inside that amplifier to the output side grounding method. So yeah, maybe there's a bit of a problem with that amplifier that you're getting alternator whine on. If you're just using 1 amp on its own, you shouldn't have any alternator whine. If you do, there's either a problem with the amp or the RCAs have a high resistance ground path or something like that, or the head unit is faulty. Kyrie says, is there trickery that can be done if you don't have space for a big enough box for subs? I've got 2 Rockford 10D4s on a 14001. With your mod, my box is too small, but boost space is limited. So, if your box is too small, okay, there's a few ways around that. The first way is add more power. If you can't add more power because the subwoofers are already at their thermal power limits, then if you can't make the box any bigger than you have it, then you can buy, if you have some spare cash laying around, you can buy another 2 of the same identical subs, and you can run them in isobaric. So look up compound isobaric on Google and you'll see what I mean. You just mount the other 2 subs onto the fronts of the 2 subs you've got in your box, and that halves the box space requirements for just running 2 subs. So if you can afford to buy another couple of subs and you want to keep everything else exactly the same, then yeah, just buy another couple of subs and mount them on isobaric. If you don't want to do that, then apart from just living with the fact the box is too small and having a slightly reduced output as a result of that, you could if it's ported, you could, instead of running a port, you could run passive radiators. Passive radiators are the same as ports, but the problem is passive radiators have a displacement limit because they're a physical moving thing. They can only move so far, whereas a port doesn't have a X-mech because it doesn't have a mass of itself. So you can use a passive radiator in place of a port if the box is too small, and what that'll do is that will free up any cubic foot that is taken up by the port. So your box won't get any bigger externally, but because you're not using a port in the box, any cubic foot that's taken up by the port is now being used as enclosure internal volume, and then you can then tune the passive radiator to the same frequency that the port was tuned at. If you're sealed, then the only option is add more power or go isobaric. Yo, thanks for the 20. Be someone, man. Appreciate you. Merry Christmas, Sam. Got my highest paid position as a general maintenance technician recently, in part from the knowledge you offer. My man, well, I really appreciate that, man. That's really, really cool to hear. And good luck to you with your future endeavors for sure. Merry Christmas, buddy. It's slot ported pretty big. Didn't you just say it's too small? But yeah, if it's ported, then yeah, you could exchange the port for a passive radiator, go isobaric, or just add more power. There's your options. Or buy a bigger car with a bigger boot. Right, let's try and actually finish an amp tonight. So I've got my 2 rectifiers in there, not soldered in or whatsoever. I just want to see whether we get any rail voltage from having them this way round, because I'm a bit too lazy to look at the board and figure out which one's which. This is much quicker. So just a quick pulse from the remote will tell us whether these are in the right way around. Okay, not got any rail voltage there, so let's flip them round. There we go, now we've got some rails. So that is the correct way round for the rectifiers. So let's turn that off and get them soldered in. Oh, the slot is big. Fair. If you've got a small box with a large port area, then you must be tuned really high. Because it's very difficult to get low tuning if your box is small and have a large port area. Do you know what's your box tuned to? Do you know? Just tack those in from the top first, just so I can flip it upside down without them falling out. There we go. Yo, Craig, thanks for the 5, buddy. Appreciate you. Thank you. Happy Christmas, Sam. Just want to see you sort my JLHD amp on stream. Is that the 4 channel that had the switches that were stuck? Let me know, Craig. Is that the 4 channel with the stuck switches that's in really bad condition? What happened to your nice small soldering iron? Oh, it's still here. My big one is just nice and hot, so I decided to just use that while it's got some thermal energy in it. Yeah, I hadn't turned my big one off yet, so rather than waiting for my small one to heat up, I thought, well, I'll just grab this one. I use this one for removing parts because it actually can reach across all 3 legs of a TO220 and a TO247. It can reach across all 3 legs of all the parts I need to desolder, and it has so much thermal mass that it just gets them out in like 2 seconds. But usually for resoldering I do use the smaller iron, just because it's easier to navigate. Okay, so that's our rectifiers back in. So I think now we should do a cheeky little power up and just make sure that neither of the output drive ICs are overheating, because if one of them is overheating, or both, then they'll be dead. And just make sure we've got all the voltages in all the correct places, and that the power supply section works, yada yada yada. This is a B2 Riot 3200. Kiri says, I'm guessing more power just brute forces the problem. I've been scared to pump the gain since modding the amp. Surprising how much power the mod gives. It's not really a problem as such. Like, basically, the smaller your box, the more power your woofer will need to overcome the air spring in the box and reach mechanical excursion limit. So, provided you are well within the power limits of the woofer, then yeah, of course you can add more power. That's absolutely fine. In many cases, having a small box with lots of power can actually be louder than having a large box with like less power, due to how the air spring in the box works. Regarding the endurance test of amps after repair, you mentioned using a static load 2 ohm with a reactive load of 4 ohm. Like, what example of a reactive load can we use? A loudspeaker driver, a spare subwoofer, just something that creates, impedance rise, something that actually opposes. So yeah, just a spare subwoofer. That's the only reactive load I can think of that is AC. Yeah, just a spare sub that you got laying around. Okay, let's power up and see what we got. Let's turn on the thermal imaging camera as well, so that we can check that the drive ICs are not overheating. So let's have a look, make sure that rail voltage is still building nicely. And 9 volts worth of rail there. Yep, so on these amps we need to pulse the remote many times. So on my foot pedal right now, I'm like pulsing the remote. You can hear it there. And on the scope screen you can see, which pedal is the scope? This one. Every time I pulse the remote we get a little bit more rail voltage. See that? So you just need to keep doing that until there's enough rail in the amplifier for it to happily power up. There we are. Okay, a lot of current is actually being drawn, and we have one of the rectifiers here heating up to about 50 degrees Celsius, so something isn't right over there. There's either something on the board which is causing a short to ground, or oh yeah, got some power supply FETs as well, getting a little bit toasty here. Got 35 degrees on there. Nothing dangerous whatsoever, but yeah, there's obviously something there heating those up. So we've got these two and these two, which are driving this rectifier here. So let's try and investigate why that is. Let's get the multimeter out and see whether we've got any shorts or anything on that. And let's also dump the rail to ground. Okie dokie. Yo, Matthew, man, thanks for the 50. Jesus Christ, that is a big chunk of money. Just in case you don't do another stream before Christmas, Merry Christmas, Sam. Here's some money towards the LTT screwdriver. Buddy, thank you so much, man, Matthew. Matthew, absolute legend. Really looking forward to seeing you again, my mate. Oh, for anyone that doesn't know, on the stream, Matthew here is the guy who appeared in one of my recent videos where we did some work on the realistic. We looked at the realistic and the Yamaha and did some fun stuff. Okay, so we've actually got a short there. I wonder whether that's a short on the board. Is it bad if I get different voltages on the high and low side of the rectifiers? Not sure what... Oh, you mean different... Like if the rail voltage is uneven. It's not usually a good sign. However, check to see what voltage is on the output side ground, because it may just be that the way you are measuring the voltage, there is a slight difference between the ground potentials. So therefore it looks like the rail voltage is uneven, whereas they're actually not. See how much longer this takes to desolder with the small iron versus that massive one. With the massive one, I literally touched all 3 legs and the thing just falls out. Whereas this one, I've got to like wait for the thermal energy to get in the board, move it backwards and forwards, etc, etc. Yeah, this is long, man. It's much easier to just use the big one. The big one's been off for about 5 minutes, but I bet it still has enough heat in it. Does it have enough heat in it still? If not, it shouldn't take long to get back up to temp. So if you get a difference of 10 volts, what voltage do you have on the speaker negative terminal? Yeah, I need to wait for this to heat back up again. Generic full bridge, yeah, this is a Chinese clone of the sound digital circuit, this one that we're working on. Oh, come on, hurry up. Maybe it cooled down more than I thought. think what I'm going to do is I'm going to try those MURS 1620s, see how they hold up. I'll run some endurance tests on it at full power and see if they're running correctly and not overheating. Okay, so make sure the short isn't in the board. No, the short's not in the board. Wide apart. Together. You can use 2020 instead of 1620. Oh, sorry, 1220. You can use 1220? Is that enough current? Doesn't 1220 mean this 12 amp? Doesn't seem like enough. Maybe it would be. Especially considering like a Korean 3K would be using, if it was using 1620s, it'd probably have about 4 of them at least. Or maybe even 6. Okay, let's see what we're saying now. So raw voltage. That's building so much faster now. Yes, that's definitely correct. Okay, cool. So we have, with the 9.7 volts worth of input, nice and low to start off with, 73 volts worth of rail, 0.7 amps worth of idle current draw with no output FETs in. So let's just see whether we have any of the output drivers here getting hot. Got a lot of heat over here, obviously, because we've just been soldering. So okay. Don't think either of those drivers are getting particularly hot or anything like that. So let's just confirm we have the correct voltages around parts of the board. So we should have a bit of DC on the high side gate and source. A little bit of, there you go, got half rail roughly, no, actually a bit less than half rail, but we've got a bit of DC on the low side drain, that's correct. Speaker terminals should have the same voltage on both, 23.5, 23.5 thereabouts. Cool, looks good. $15 volts. Okay, cool. Everything looks to be in order. So what we're going to try and do is fit some new output FETs and see what happens. Can I run 2 identical amps side by side to 2 identical subs that are sharing a box? 1 amp per sub, 1 amp per sub, 2 subs, 1 box without issues. Yes, but the better way to do it is to wire, how to explain this in a way that's easy to understand. A better way to do it is to wire coil A from both subs to 1 amp and coil B from both subs to the second amp. That way, if 1 amp fails or is for some reason outputting a different level than the other amp, at least both subs will still be getting the same total amount of power, because the power imbalance will be between coils which are fixed to each other, therefore they can't move independently from one another. If you've got 1 amp on one sub and 1 sub on the other amp, then you've got a massive risk there of any slight differences between those amps or outputs causing massive loading differences in the box and could very easily damage mechanically your subs. So wire coils A from both subs to 1 amp on coils B from both subs to the other amp, therefore both subs will always be getting the exact same signal regardless of what the 2 amps are doing from each other. Dexter says, I don't know why I enjoy watching a guy in a Christmas sweater fix amps I know nothing about, but I do. Well, I'm glad you enjoy it, my man. Yeah. Glad you enjoy it. I actually have a similar thing. I used to enjoy watching, before I was even into electronics, like I didn't even know I was into electronics. I used to watch Lewis Rossman repair MacBooks. I had no idea what he was doing either, but I found it entertaining. So, alright, let's grab some 4115s and load them in and see if we've got any drive circuit faults. Where are all my flapjacks? I should really label these. Actually, guys, every single live stream that I do, can you just remind me to label my drawers, because it would save me so much time. Where are my 4115s? Okay, I think there's some in here. 1, 2, 3. What was that? That is a 4, but that's not a new one. What's the batch on these? RKXY. Oh, come on, as if I only have 3 left of the same batch. How has that happened? Because they're only ever fitted in even numbers. How have I got 3? Fine, I think these ones here with some thermal paste on them have been taken from a amplifier bank that didn't fail. So what I'll do is I'll temporarily solder them in for now, but that means I need some more 4115s. How have I got 3? I must have dropped one on the floor and not realised. Unless they could be... Now they're all on the floor. Unless they could be in this drawer, which is 150 volt TO220. Here we go. Right, what we've got in here? Any 4115s? Any new 4115s? This drawer, to be fair, is just mostly for part used FETs, so I don't think I've got any new ones in here. I've got some 3415s, probably no good for this amp. No, no, nope. Okay, let's go with these ones and order some more to drop in when they arrive, but let's just temporarily whack these in for now. Just see if it works, do some endurance testing. Vijay says, how's it, Sam? First time on your live, all the way from SA. Wow, nice, man. I'm known as Amptronics in South Africa. Nice. It's cool actually. It seems like there's a couple of guys in South Africa repairing amps, which is cool. It's good to have a couple of. I mean, I say that if there was more than one person repairing amps in the UK, like big Class D amps, then I'd be out of business because there's not enough work in the UK for there to be more than one. Really, actually, there's not enough work as it is. But yeah, it's cool that there's a few guys out there in South Africa, perhaps. I just started labeling my drawers. Have a paint marker hanging there and a not saying label these. I've got actually a label machine. Yeah, I've got one of these Dynamo things. Dymo. Got one of these label machines. I bought this specifically to label my drawers, and instead all I've done is label the spices in the kitchen. Great idea, David. That is a fantastic idea. You're full of great ideas, my friend. I should hire you as my idea maker. Hope the lack of work coming in has recovered. Not really, unfortunately. So yeah, basically, I think it's for a few reasons. I think parts have gotten way more expensive. So it basically what it is. So I'm actually looking for like what else I can do, because repairing car amps is actually not doing me so good anymore these days in terms of finances. So I need to figure out what else to do. I think it's partly due to parts prices have gone way through the roof. So I'm either having to charge more for repairs, which means that people are less likely to want to get their amp repaired, or I'm having to take less money on a repair because more of it goes in parts. But also, I think just a decline in the interest in car audio in the UK, for one. Or maybe people just in hardship and they can't afford to like pay out for amp repairs, so they're just kind of getting out of the audio game when their amp doesn't work, or just buying a new cheap one. Another thing as well, amps have got like power has got so cheap. So if someone's got a big old amp that needs repairing, it might cost say like £200 or £300 to repair it. Well, you can get 5,000 watts RMS for like 250 quid. So it's just becoming less and less viable for people to pay for repairs now. So I got to find me something else to do, bro. So what do we reckon then? Is the drive circuit okay? It's interesting because the output FETs failed in such a dramatic way, which is unusual. I'm a bit unsure as to whether the drivers would be okay in this instance. Part of me thinks that maybe they would be okay because all of the energy went into burning the FETs rather than getting shoved back down towards the drivers. But also the fact that there was high voltage there burning away at the FETs for so long makes me think maybe the drivers did get damaged because it was there for a long time. I don't know. Only one way to find out. Any chance getting my DD9500 repaired? If you're in the UK, yes, you would need to speak to Pooven, who is the Digital Designs distributor for the UK. Although saying that, the wait time on parts is like gonna probably be about 9 months, if they even have the parts or can get them. So technically, yes, you should be able to get that fixed, but realistically, it might not be for a fair while yet. Priorities, yes, absolutely. The spices were very high priority. Do you have any experience on vinyl LP? No, none in the slightest. Conrad says the motor comes off. Oh, we spoke about it already. I think, didn't I say that I could maybe do it, but maybe next year? Like, that's not really the sort of repair that I want to do. That's that needs to go back to DD in the States to be repaired. I have done repairs on shifted motors before, like regluing top plates and stuff, but I've never done it on a motor that is as strong as the 9500, and it's going to be quite dangerous to do. What really needs to happen is the motor needs to be demagnetized at DD using their machine, repaired, remagnetized. Yeah, not really something that I want to do particularly. It would take me ages, even if I could do it. Right, there we go. There's 4 new output FETs fitted. So yeah, let's just see whether the drive circuit survived. If the drive circuit does have damage, it shouldn't kill the FETs because there's not that much energy in these rails, and the way that these drive circuits die, basically it just won't switch, or it will just give DC offset at the terminal. It's unlikely to actually kill the FETs from having a dead drive circuit in here, especially because we're current limited. So let's see then. Let's just make sure that we have the correct gate resistance between these. We're not going to have any. Oh yeah, the gate resistors are on this amp all the way back here. This is actually a pretty bad design. The gate resistors should be as close to the FETs as possible, whereas on this amp the gate resistors are way back by the drive IC. And they're only 1 ohm as well. They're 1 ohm gate resistors, and they're way back by the drive IC. Not really the best design. They should be right by the FETs. The gate resistors are fine. So let's see what she does. So we're going to probe the low side drain. I'm going to probe the low side drain of the bank that failed, which is this one. So we've got some rails going in now, as you can see on the scope screen. And 14.4, 13.7. Yeah, let's just see whether this gives us any Class D switching. I'm also going to just put a load across the speaker terminals. It's really important on these amplifiers. They actually have a load on the speaker terminals at all times, because the filter network is very, very weak. It's not a very deep filter circuit, and sometimes you can have weird glitches where the filter network breaks down, the inductor stops being an inductor, and it actually shorts the rail switching to the capacitor, which will kill the output FETs very quickly. So let's do that. Hey, there we have some switching. So the drive circuit was absolutely fine. So all this needed was new FETs and new rectifiers. With a little bit of luck, we can make it through tonight. Did you see there at the start of the where am I? Did you see that at the start of the switching, the rail voltage sunk down quite a bit? So if we start here, ooh, you see how much it sort of sinks down from? Let's have a look at the rail voltage. So that's kind of like freewheeling. So before the output section actually starts drawing any current, the rail voltage starts kind of freewheeling way up to about 75 volts there, I think that is. Yeah, 75 volts, and then as soon as the output section starts switching, it pulls it down to 70 volts, which is probably nearer to its actual current bearing voltage. And when you start drawing current to drive a speaker, that will drop again. I've actually got my dummy loads hooked up right here. They're only wired to 16 ohms, so I use 16 ohms to short out rail caps because it's quick enough that it's convenient, but it's high enough of a resistance that it doesn't cause a massive spark. Because I've got 16 ohms hooked up, I should be able to drive that load a little bit by hooking up an RCA with some signal and just seeing whether the rail voltage drops down at all. Now obviously 16 ohms is not a very difficult load to drive by any stretch of the imagination, but it'd be interesting to see how far away from the kind of main current bearing voltage that is. That's 70 volts. Also worth remembering that we don't actually have these FETs mounted to a heatsink, so we shouldn't do this for more than a couple of seconds really, because they may overheat. Let's go with about 50 hertz on there. Okay, yeah, we've got some signal going in there, 50 hertz, drawing 1.6 amps, which is 0.4 of an amp more than idle. So if we have a look at the rail voltage, which is just here, does that sync down as we turn up the gain, turn up the signal level? It does a bit. Need to turn my thing up a little bit. Yeah, it drops it right down to 65 volts. So even with just a 16 ohm load and nowhere near clipping, the rail voltage sinks down to 65 volts from 70. So under heavy load, you can imagine how much that's going to sink down by. And the cause for that is going to be as a result of voltage drop across many of the things that are supplying this. So we're going to have voltage drop across the rectifiers, which are not that warm, but they're a little warm to the touch. Could be from soldering still, but they're a little bit warm to the touch. So voltage drop across the rectifiers, voltage drop across the traces, although they're not particularly long or anything, so they wouldn't have much trace resistance. Voltage drop in the transformers. And then we'll also have voltage drop across the power supply side and also these wires. I mean, we have a maximum of 20 amps we can draw from my power supply, but there will be a little bit of voltage drop across the power wires going in here as well. So yeah. What amplifier is this? This is a B2 Riot 3200. So it's just a Chinese sound digital copy. Blake says, I work at DD and we just got a ton of parts in. Oh, nice. Because I know you've been struggling with parts for a long time. But yeah, I need a magnetizer in order to fix a shifted motor. I've fixed some shifted motors in the past without, but they've been much smaller. They've been smaller, like I fixed an Alpine Type S. I fixed a Phoenix Gold. Can't remember what the heck it's called, but it's one of these ones with the little triangle with the LEDs in the triangle. It's quite a nice sub actually. That had a shifted motor. I fixed that. Yeah, it was just a case of getting the top plate off of the motor where it had like shifted and locked the coil against the pole. Yeet that apart, and then take all the soft parts out. So you're just left with the basket with the top plate on it and the motor, and then using a shim and carefully with something in the way putting the top plate back on the motor down through the shim. I think I used a bit of wood to kind of allow the top plate to go down onto the motor without shattering, get it like close, and then slowly pull a bit of wood out, and it sort of like slowly goes down onto the magnet with some I think I used araldite to secure the two things together, and yeah, none of them have ever come apart again. So but yeah, anything bigger than that, like I would be very scared doing that with a 9500 series digital design sub. Like it would either be a case of broken hand, like getting the hand stuck and trapped between the motor plates, or just shattering the ferrite, or just being unable to overcome the magnetic strength and actually get it off in the first place. So yeah, cool. This amp seems to be working fine, producing audio. I do want to get some brand new 4115s on this though, so I'm going to just put this to one side for a bit, order some new 4115s. Maybe we'll do that on stream, see if I can get a good price on some. Or something similar. It doesn't have to be 4115s. They are a great part, but if they're really, really expensive and there's something that is comparable that is much cheaper, then we can go for something else. But yeah, I want to do some testing on this one. I want to do some testing on these rectifiers as well. before it goes back to the customer. So this is fixed, but by no means finished, but we'll do that some other time. Nearish, yeah, you definitely can power these out of the case. And obviously these are very efficient amps, so they're not going to get as hot as something old school out of the heatsink. But yeah, so especially Class AB. If you've got Class AB, don't even let it idle outside of the heatsink, because it needs that thermal coupling between the biasing transistor and the output transistors in order to prevent going into current overload, current runaway. So let's drop that down there for a bit. Let's move on to something else. Okay, guys, I'm going to let you decide what we do next. Can I start a poll? Okay, poll, what next? I have got a similar circuit to that. I've got a Def Bonds. Let's just call it Apocalypse. How the fuck do you spell Apocalypse? I don't know. Def Bonds. Small 4 bridge headache. I'm actually really struggling with this one. So I've got one amp that we can look at that I'm actually having a massive struggle with, that might take the rest of the stream to figure out. I can do a Vibe Mono Box 4 old school HIP 4080. I can take a look at this, another headache amp, JL Audio HD 751 headache. Another one that I'm having a massive problem with that I can't seem to figure out. I think that might be it for stuff that I could realistically do on stream tonight. So let's see what you guys want to see. You can use IRFB 4321. Yes, you can, although they're not quite as good as the 4115s. You can use, I think it's a 75 NF015, I think is also another option. That's not too bad. Yeah, plenty of options for output FETs you could use. Okay, seems pretty even-ish so far, but a bit of a slant towards the Vibe Monobox. So yeah, the Vibe Monobox is an old school 1500 watt amplifier. It's using the HIP 4080 chip, which was used in like 90% of Class D sub-amps from like the 90s and early 2000s. Really, that chip was only designed to run amplifiers up to about 4 to 5. I think it was designed to run amps up to about 300 to 500 watt RMS. However, by using some buffer network after the chip and some other trickery, they managed to squeeze 1500 watts out of a circuit using that chip. It's not very strong for driving FETs, so it needs buffers if you're going to run anything bigger than, you know, a couple of FETs off it. Okay, now we have the JL Audio in the lead. Here's the JL Audio. This one has drive circuit issues for the output section, and it was giving me a massive headache. It's not switching. I'll tell you what the issue with this one was. The issue is that the duty cycle is not 50%. And I replaced a bunch of parts, because I actually have, which is the most ridiculous thing, I have a complete spare board for this, right? So this is a JL Audio HD 750/1 that was water damaged in the power supply side or something. But basically this board was not recoverable. The output section, however, was completely fine. Nothing wrong with the output section in this amp whatsoever. So I have a completely fine functioning output section here, that I can't actually get running because it has other issues due to water damage. But the output section here is totally fine. So this one has output drive circuit issues. So I should very easily be able to fix this one with the parts from this one. But I actually just went ahead and swapped out part after part after part, and still can't seem to figure out what the issue is. Man, you guys are really torn here between the Vibe Monobox and the JL Audio. Thanks to Matthew again for the £2, mate. I hope you have your wire glue ready for the MB4. Yeah, man. If you've been with me for a long time, you will maybe remember an old video I did where I owned a Vibe Monobox for myself, and it had the classic snapped rectifiers. It's probably one of the most common issues with the Vibe Monobox 4 is snapped rectifiers, and I tried fixing it with wire glue, which is thermally conductive glue. Didn't turn out too great, to say the least. Well, it's going to be the JL Audio by a smidge. We've got 38 votes, and it's 42% JL Audio, 37% Vibe Monobox. So we'll have a look at the JL Audio, but if we don't really seem to be making much progress, then we can always turn to the Vibe Monobox, because that should be relatively simple to fix, I hope. Just check my phone real quick. Can feel it buzzing. Okay, so what have we got ourselves into with this? Let's try and find the need to try and find the power block for this so we can get our wires hooked up. Now, where would I put that? Where did I put the power block for that? So, screws. There we go, there it is. Okay. Aside from this headache, is JL Audio good? I would typically say yes. I have respect for JL Audio because they design all of their stuff themselves from scratch. Not only their amps, also their subs, all sorts of stuff. Everything JL Audio, pretty much everything JL Audio, is designed from scratch in-house, which is why it demands the premium price that you pay. However, I do think a lot of their circuits are overly complicated, and as a result of that, they tend to fail more often than perhaps a more simple version of that circuit would otherwise do. I do get quite a lot of JL Audio in for repair, but that could just be because there is a lot of JL Audio floating around, and people that own JL Audio amplifiers will want to get them fixed because they're expensive, rather than just throwing them away. But yeah, I do seem to repair a lot of JL Audio, and they seem to be a bit of a headache when they do go wrong, as is this one. So, okay, let's. Oh, we're 50-50. We're 40% on both. We need one vote to. Well, I've got the JL Audio out now anyway, so we're going to do the JL Audio first, as that was in the lead for the most of the poll. So, we'll show you what it's doing first. I shall power it up, and we'll have a look at the output switching wave. Now, these amps are regulated, so choosing a low input voltage isn't really going to do much for me, but we're going to stick with 10 volts anyway. and the rail voltage in these amps is actually really high. It's up at like 95 volts or something like that, because these amps do the same power through, I think it's through 1 ohm, 2 ohm and 4 ohm. I think it does the same power all the way up through 4 ohm. So obviously we need pretty high rails in order to do that sort of 750 watts up at 4 ohms. So yeah, they are pretty high internal voltages. So okay, let's power it up, just check it's still okay. Just haven't looked at it for a couple of weeks now, and it should still be doing the same thing on the output FETs. Any leads on replacement inductors for slash amps? No, actually. What did I do to fix? I actually did have a slash 500, I think a 500/1 that had a damaged output inductor, and the way that I got it fixed was I waited until I was repairing another 500/1, removed the working known good inductor, measured its specs, measured the inductance and the resistances and stuff on it, and then for the one that was broken, I actually dug through my set of donor boards, spare amplifier boards that are donors, and found a similar, close enough output filter inductor to fit that was pretty close to the original 500/1 specs, and fitted that, and it hasn't come back, so I guess it was good. But yeah, getting original replacements I don't think is viable, so I just used a similar one and it seemed to be fine. According to manual it's 1.3 to 4 ohm. Yeah, okay. Whew. Okay, so let's have a look at the scope screen. I keep pressing the wrong freaking button. Scope screen is here. So this is our rail voltage. We yeet all the way up to 120 volts, a bit higher than I remember. And in terms of the outputs class D switching, this is what it looks like. So as you can see, that's not right at all, is it? And it's the same on both sides. So this is a full bridge amplifier. Sort of. I say it's a full bridge amplifier, but it's a bit of a weird one. It's not full bridge in the normal sense of full bridge. So this bank of MOSFETs, this sort of this right-hand bank of MOSFETs, has this drive wave on it, and this one has this one. Now these both need to be at 50% duty cycle. They need to be both at 50% duty cycle, because if there's not, then the fact that they have different duty cycles will mean that there is a large DC potential difference on the speaker terminals, which is what we have. If we measure the speaker terminals here, you can see that on one terminal we have 103 volts, and on the other one we have 15 volts. So that is going to cook a speaker in no time. So it's a weird one, because the drive circuit is kind of working and oscillating, but the input to the drive circuit is wrong. These drive buffers that this amplifier uses, these are using 2010S IR2010S chips, and they're very simple. They just have an input for both high and low side and an output for both high and low side. They just drive the FETs. So they are being fed with the wrong information, and that information comes from this circuit here. So I have this amplifier, which was the water damage amplifier. As you can see, there's a bunch of water damage over here, with this circuit completely intact, no problems with it whatsoever. And I've tried swapping all of the chips and op amps and all sorts of bits and pieces from this one to that one, and it hasn't really made it go away. We have the correct supply voltages. We have plus minus 5 volts here and here, and we have plus minus 15 volts here and here. No problems whatsoever. There's no problems to the supply voltages to the circuit at all. So it's just going to be a case of finding out what the bloody hell is wrong with this circuit. And it's likely going to be either some DC being leaked into one of the op amps or something along the drive path, because some DC leaking in there will shift the duty cycle up or down a bit, I think. Or it's going to be a capacitor that is out of tolerance. Nothing has burned or failed, so I don't think it's going to be a resistor that's out of tolerance. So it's going to be a little surface mount capacitor, or an op-amp, or transistor, or diode that is failing internally. Is that not a feedback loop issue, eBerg amplifier repair? Possibly, I don't know. Because it depends whether this amplifier is self-oscillating or not. I can't remember if these are self-oscillating or whether they have an actual oscillator. This could also be DC being injected into the preamp, but given that we don't have the preamp board connected, it's not going to be that. So yeah, I think that the quickest solution, the quickest way forward, is just to start replacing bits from this one that we had that was known working output section with this one that's got issues. And if that doesn't work, then we can sort of dig further into the circuit and try and figure out what's going on. Because the answer is here on this board. We just don't know where it is. But it might be quicker to just swap parts and hope that we strike gold, rather than actually trying to dig into the circuit and figure out which part is actually wrong. Yeah, a lot of the chips actually, you can see I've removed them from here and I haven't put them back on here. So I can see what I've removed already and see what I've actually swapped out already. Have I swapped this chip? Possibly, it's hard to tell. That's the problem, my soldering has gotten to the level now where I can't actually tell what I changed already. unless there's solder flux left behind, which I usually clean off. I can't actually tell what bits I changed already. So maybe I'll just start changing some random capacitors and see where we go. A bad feedback loop on an op-amp could make it do that too. Okay. The other scary thing about this is this circuit is almost working, and I don't want to mess something up that makes it very not working, if you know what I mean. Maybe I should start by just swapping out a bunch of surface mount caps. What do you reckon? Maybe I should start probing a bunch of surface mount caps and see if we get anything weird on any of them. Okay, well that cap has absolutely nothing on it. I don't know if that's normal or not. Actually, a lot of these stuff don't have anything on them. Why don't you hook up both boards and test them back and forth? Well, because as I explained, this one is completely non-functional because it is heavily water damaged in this part of the circuit over here. Like, all the traces are completely gone, all the original parts are completely gone. It's heavily water damaged, and this has been a donor amp of mine for a long time now. So this amp is never ever working again. So I can't power this one up to compare voltage readings and stuff around it. All I've got is I've just got a selection of working components that I can swap between. I can't actually power this one up. Interestingly, most of these tiny surface mount caps don't actually have anything on them on either side of them. Yeah, like none of these have anything on them anywhere. Apart from that one. It's 9 volts on one side, 9 volts on the other side. That one again has nothing on it. That one has -3. Okay, shall we see if anything's heating up on here? That'd be a good thing to check next. Okay, so the output MOSFETs, they do heat up. Got about 53 degrees, not like super toasty, but they are heating up a bit. Anything else on here? Not really. Okay, there's a few op amps up the top here that are getting hot. Got a 38 degrees on one of these, I think it is. I might try swapping some of these out, just see if they do anything. 39 degrees on one of those op amps. Output FETs are now up at 65 degrees Celsius. Okay, I'm going to try swapping out some of these smaller op amps up here. So we got 1, 2, I'm going to go for 1, 2, 3, I think. Doesn't look like I've changed that one. So I'll try these 3, try and swap out these 3, see if that makes any difference. Just in case we strike gold with any of these. $75. 75. Okay, let's get the hot air gun turned on. What probes do you use for your scope? I don't know, just really cheap ones. The work that I do is generally pretty high voltage waveforms. Even like 5 volts is a high voltage waveform compared to a lot of low logic stuff. So, and because it's not particularly fast either, you don't need really expensive probes when you're doing amplifier repair work. The frequencies are just not that fast. Most of the time with doing amp work, you just need to make sure that the waves are there and that look the right kind of shape, but you don't need to be like proper honing in on the tiny kind of like ringings on, you know, you're not doing any design work for like computers and stuff. So I enjoyed the last driving video you did. Very good content. Thanks very much, Henrik. Appreciate that. I'm glad some people like that one. Okay. So, one thing about gel audio boards is they have a really high thermal mass. So I might need to sit here and blow on these for longer than normal. Be best actually to preheat them. Work on computers as well, so looking for something pretty decent. I honestly don't know, because I only buy cheap probes, so I'm not the best person to ask. Oh, came off pretty easy. Okay. So get the other one off of the donor board. Okay, it's looking good. So let me just drop this one onto the donor so I don't lose it in case I need it in the future. Okay, that's one down, so let's go for this next one here. Cool. Yeah. Where did it go? Where did it go? It seems much harder to desolder off the donor board for some reason. Jesus, come on. Bloody hell. I don't know why that was so hard to get off that donor board there. It came off really easily on the main one. Nope, not happy with that. Bunch of bridges. Let's try again. Right, that should do for that one. It's a little bit off on the top set. There we go, that should do for that one. And lastly, this one up here. These are much smaller than your average sort of TL072Cs and stuff. These are a much smaller package, these. You have to be a bit more precise, a bit more careful. Okay, 1, 2, 3. I think that's good. That's those 3 op amps. So I'm just going to drop them under the microscope just to make sure that there's no solder bridges or anything like that. Make sure they're lined up nicely. It's always just worth double checking. Let's drop that down a bit. Yep. Get some isopropyl on it as well. Okay, that one looks good. This one. is a tiny little bit off to the left, but like that's just me being fussy. That's absolutely fine. And hang on a minute. Is it me, or does R158 look a little bit crispy? Looks a bit burnt to me. It does actually measure correctly. It does actually read the correct resistance. Now, is that burnt, or is that just some resistors are just black out like that? I have seen some resistors that aren't marked and that are just blacked out like that. It doesn't really look burnt, but on my donor board it does have an actual value. Maybe I should just swap it anyway, because on my donor board it is valued. And then I think what we'll do next is we'll actually see what that resistor connects to. Because if it was burnt out for some reason, then that gives us an indication as to where the fault lies. Now, it's almost like the solder on this donor board is like different. It's way harder to desolder stuff from. A little bit of flux and that should snap into place. No satisfying snap, but that is... Be neat and tidy, come on, be neat and tidy for me. It's like the tiniest thing ever. Come on. Get into place. There we go, that'll do. That's fine. That'll do. So, yeah, it was reading correctly on the multimeter, but let's just see, where does that go? That trace, let's have a look on the donor board, because the donor board is has those parts removed. So that does actually go to pin number 1, 2, 3, 4, 5, 6 there. And then where else does it go? It goes through a via under the board, which I don't know if I'll be able to follow, because this board is multi-layered. Yeah, I don't know if I'll be able to follow the trace on that, because it's mega multi-layered. I'm just getting that original resistor from the amp soldered down so that it doesn't disappear, just in case for whatever reason I need it again. Okay, so now let's power it up again and see whether that's made any difference. Swapping out those bits there. Turklo says, check the diode on the first op amp you showed. It is part of one of those inverting inputs. If it's bad, it will peg that op amp to its rail value either way. Okay, let's have a look. I think I did go through with a multimeter, just checking bits and pieces, and didn't find anything untoward, but let's have a look. So the first one that we showed was this here, D12. So we have the D112. So we have 562 one way round, and the other way round we have like open, but we're reading some other stuff in the circuit. On the donor amp we have obviously the donor amp might be different because there's missing components. 555, and the other way round is fully open, but we are missing some components. But maybe I'll change it anyway, just because it's one last part. So maybe I'll just change it anyway. What's up, Mike Honda? How's it going, buddy? Okay. So let's see if that's made any difference. Oh my god, I'm getting like a quadzillion eBay messages here. One second. Jeez. Okay. Right. Power it up then and see if that's made any difference. We have rail voltage on, I can't remember which one was which, but let's just go for this one. Huh. Okay, well now we have no switching at all. That's interesting. We went from some switching to no switching, and all we did was change some parts. But what we also did is we heated the board, yeah? So the board is now much warmer than it was before. So it's possible that maybe failed parts are around this area. There are actually a couple of other resistors that are kind of black on the top there, but actually it looks like that's just how that is designed. Like there's loads of resistors that just have a black line as opposed to their actual marking, so I think that's just how this one's been designed, honestly. Like I see that in some other amps as well. Okay, let me try injecting a sine wave. We have nothing on the speaker terminals now. whatever this op amp is, it's got 15 or 16 volts plus minus around its whole shebang, around its whole thing. So is it me or is the camera really dark all of a sudden? It just looks really dark to me. I think we should be getting some Class D switching right about now. What do you reckon? Inject some signal and see whether that does anything, because injecting some signal, even if it doesn't work, if there is an issue it will maybe point us in the right direction. But I think it's definitely around this area then, isn't it? If we just change those 3 parts and now we don't have any switching, it doesn't really make a lot of sense. Going to try cooling off the board a little bit with some isopropyl alcohol spray. Just kind of spray it on here. Here's the preamp board, so I could try connecting this up. Okay. Okay, so let's inject a bit of signal and see what that does. So we got RC inputs over there. Where's all the controls on this amp? Oh, it's over this side, isn't it? Frequency, filter, input sensitivity down, input voltage low, infrasonic. Okay, so the gain is basically this middle one here. Okay, so let's see what happens now we've got some signal going in. Okay, signal does absolutely nothing. Loads of signal does nothing at all. In terms of the amplifier status, we actually now have a red and green light, so it's like a kind of amber light. Whereas before, I think it was green, but I wasn't really paying much attention to the light LED status, so I'm not entirely sure. Okay. So yeah, signal doesn't do anything. So we've made it a little worse by just swapping out those parts, which is really weird. Maybe I should start swapping some of them back and see when the issue comes back. So those op amps I removed, maybe I should just try swapping them one at a time and see if the original issue comes back, perhaps. So first thing I'm going to try and do is I'm just going to swap that diode back. What the fuck was that? I'm just going to try swapping the diode back. I want to see if that has anything to do with it. Okay, power on, let's have a look. Helps if I have that power connected. Okay, so no, that didn't make a difference. What is on this diode now? Plus 15, negative 15. So that diode is fine in itself. So let's try swapping one of these op amps again, maybe, with one of the ones that we took it from. Yeah. Is that sketchy op amp still getting hot? That's a good question, actually. We could have a look with the thermal imaging camera just to see whether there's any difference in the heat now. Problem is we've been soldering, so everything's going to be kind of warm. They're getting to about the same temperature that they were before, so yeah, nothing really strange there. Maybe I should try swapping out some surface mount caps first. Actually, you know what? A schematic would actually come in real handy right now. I don't know if there are schematics for the 750 slash, the HD. So in terms of likelihood of the thing that's the problem, If it's not a semiconductor, the next likely thing is it's going to be a capacitor, surface mount cap. That's the next likely thing in order of likelihood. See, this doesn't really take too long, so it's worth doing. Just, you know, this is probably going to be quicker than if we start trying to reverse engineer the circuit and work our way backwards, trying to figure out what's going on. If we can put the nail in the coffin quicker just by doing this, then that's worth it for our time. Seeing as we've got the advantage of having a donor board here that has allegedly all the working parts on it already. Even though it would be more educational to actually figure out what is wrong classically with this. But yeah, time is money. Okay, 1, 2, 3. Let's do C151 as well. Okay, So there's a bunch of surface mount caps. So that wasn't me whistling, by the way. My phone was going off for once. Usually I do whistle, but no, it's just my phone going off. So that's a bunch of surface mount caps changed out. Let's see if that's made any difference. It's a place to start, isn't it? And one of the reasons that I done that is because we changed the op amps, which wasn't the issue, because if it was the issue then it would have started working, because we're fitting known working op amps. But around the op amps are the capacitors, and when you heat a failing capacitor you can actually change its internal structure and cause it to fail more, or sometimes bring it back to life temporarily. But so the fact that we were heating around these op amps makes me wonder, okay, maybe it is one of the surface mount capacitors around this area. So let's see what that's done. Are you ready, kids? Okay, that hasn't done anything. So we still have the same issue. Okay. I might put the original op amps back in because I want to understand why that change has happened. If we put the original op amps back in and the weird switching is back, then it's either because these op amps are actually different. They're the same model, but they're different batches between these two amplifiers. So if we put the original op amps back in and it starts doing the weird switching again, then we know that it's just due to tolerance differences between these op amps that's causing that kind of switching to appear as a result of whatever fault is going on elsewhere on this board. But if we put them back in and we still don't get any of that weird switching, then we know that the issue has now changed as a result of our heating. This one, that's fine. That's just the diode that was in here. Just flip that over to the donor board. It's well away from any exposed traces or anything like that, so. Scope the op amps is quite tricky to do because they're so small. I'm quite scared of slipping my probe and killing even more. What ICs are used to drive the transistors? It's 2010s. The drive ICs are not the issue on this. The issue is deeper in the drive circuit. Don't think I've changed whatever this is yet. I think that's one that I haven't changed yet. So let's just try changing that. I think I can tell by the soldering on the donor. Because on the donor board I'm not trying to resolder everything perfectly, because it just needs to be on there. Still trying to get you to work on my amp 5 years later. What amp is that, buddy, and whereabouts do you live? Also, is the guy who asked me about working on his JL audio amplifier at the start of the stream, is he still here? I don't know if I ever got a response from you. Let me know if you're still here. I think you sent me £5 and you said just trying to get you to work on my jail audio amplifier live on the stream. If you're still here, please let me know, because I want to ask you a couple of questions, if that's all right. Stephen says, have you found any other amps that do what the old Koreans do and turn on the PWM before turning on the switching signal? No, haven't come across any other amps that do that, because that is stupid and just something that the Koreans would do. Did you ever respond about my 250.4 Rockford? Don't think so. Shoot me the message again. Sam, does the drive goes through that small transformer on the board? Something tells me it does, but not sure. Small transformer. Which one? Do you mean this one? That's for the auxiliary supply. That's nothing to do with the drive. This is the inductor. Don't see any other small transformers. Let's see if that changed anything. Nope, still the same. Sheesh. Alright, I'm going to put the original op amps back in then and see if the weird drive behavior comes back or not. No, the first one I pointed to is the auxiliary supply. That's nothing to do with the drive. So I'm going to do this one at a time. So I'm first of all going to put this original one back in. Okay, that's that one back in. Let that cool down for a minute. I've got a Type 4 Class D that has a wicked turn on pop after repairing. Any ideas where I should look to try and track that down? Whew! Yeah, that's not good. Well, what's interesting is you shouldn't have a... So basically, Type 4 Koreans should have relays. Okay, the relays turn on like way after the switching enables. So, can you confirm that you get a turn on pop quite a while after you turn the amps on? So when the relays click in, is that when you get the pop? Or do you get the pop before the relays have clicked in, which wouldn't make any sense, unless the relays are just like forced open, have been bypassed or something? Do you know who repaired it? Did you repair it? Did you send it in for repair somewhere? Okay, let's see if that's made any difference replacing that one op amp there. Oh, 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 we got something. We got like little pulses now. So that has changed it a bit. Oh, it's actually even pulsing even after I've taken my foot off the remote. Okay. Oh, we got a little bit of PWM there. Do you see that? Just when I first applied the remote, I got a little bit of PWM. Like a tiny little bit of PWM, and then it's just pulsing like this. Okay. Bit confused now. Maybe I should put all of those original op amps back in now I've changed all the caps. Oh man, I am pretty confused. It's definitely something to do with this circuit though, isn't it? But the op amps from the donor board are definitely good because the water damage had nothing to do with the output section. None of the FETs were damaged. The water wasn't anywhere near that part of the board. It's really weird. Oh, it's a sorry, it's a SCAR RP2000. Oh, Type 4 is the generic Chinese thing, isn't it? Yeah. If that has a turn on pop, does it work fine otherwise? Yeah, those don't have relays. See, usually if there was a drive circuit issue, it just wouldn't work. It would like try and turn on and just like fucking fail. I would say that it probably just needs the drive transistors changing again, if they weren't already changed. The 2X2T transistors. Could also try changing the optocoupler on both sides. Nice shirt, Sam. Thanks, man. Good old Zelda Christmas jumper. Does the SD3K and 2K have the same... Yes, it does use those drive chips, buddy. Could do. I'm just going to try swapping this one out now. I'm going to swap this one with... Yeah. Let's put one of these back in over here. Did I change that cap? I don't think I did. I'm going to try changing C161 as well. Did I change 162? I did change 162. Works perfectly fine otherwise. Yeah, I don't know. It shouldn't have turn on pop. So fixing a relay is just a band-aid. You need to fix the actual problem that's causing that in the first place. I would probably change the drivers first and see what it's doing. I would personally get it up on the scope and see why it's doing turn on pop to start with. And then depending on what I see on the scope, I'll then go from there, changing bits. So that's that one replaced now along with that cap. WM back. Okay, now we have just this. Now we have the same issue we had at the start back. Okay, well that's kind of interesting. So that was from changing that one. So maybe I should try changing that one again for like a different one. So it must be something around this area, maybe? If that influences it. I think I've changed all the little surface mount caps around there. Maybe swap these two round, see what that does. Okay, so now it has all the original op amps back in place. Right, let's power it up again and see what it's doing now. Interesting. Okay. So yeah, it's just doing the same as it was when we first got it in. Okay. So we haven't made any progress, but I think we now know that the issue is likely to be around this area. Seems that as that's what seems to be affecting the drive. So maybe man, I don't know. I do not know. Don't suppose there'll be a schematic anywhere for these. What's weird is that like a bunch of these transistors at the top here don't seem to have any voltage on them like whatsoever. Like surely there should be some working voltages on these parts. 4 volts, 3 volts. Is there any drive going through the op amps? Looks like part of the signal is getting lost somewhere. It's not. It's that duty cycle needs to be 50%. So whatever is kind of generating the switching frequency is not doing so correctly, or there's like some DC being injected there somewhere. So a schematic would really help right now. Let me have a look and see if I can find a schematic for this. Have a look on one of my Facebook groups that has a bunch of us repair techs in it, and see whether anyone's uploaded a schematic for this or similar. Can I search files? You can't search files on mobile. Lovely. I have to do it on the PC then. Have any manufacturers tried to hire you to come and work for them? It's one thing to repair amps, and it's another thing to actually design them from scratch. Just having a quick look online right now. Files, search files, HD. Nope, 750. Nope. JL. Nope, nothing JL audio in here at all. Shit. Alright, let's start probing stuff. I'm a bit skeptical and scared to start probing stuff around here because it's all so small. I don't want to slip my probe and blow something up. Alright, let's have a probe of this area then. So let's try probing this one, see what that does. I'm just probing the FETs again just to make sure it's all good. Okay, so nothing on pin 2. Pin 1. Nothing on pin 1. Nothing on pin 3. Pin 4 we have negative 15. Pin 5. Nothing at all. Pin 6. Nothing at all. Pin 7. Oh, pin 7 is doing something interesting. Pin 7 is all over the place. Pin 7 is jumping between levels. Down -13 and then jumping around like absolute mad. Pin 8 should be +15. Yep, there we go. Okay, so pin 7's definitely acting strange. It has some kind of noise on it. I'm going to AC couple pin 7. Look, if I AC couple pin 7, let's see what we got on pin 7. That doesn't like look right to me, you know. Just it kind of looks like a kind of faulty thing. Jesse Messi, yo, thanks for the 20. Merry Christmas to you too. Thank you very much for that. Okay, so pin 7 is acting strange. Let's have a look at some of the pins on these other ones. So let's go for pin 1 on this one. Got 15 volts, pin 1. Pin 2. 15 volts. Pin 3. Nothing. Pin 4, obviously -15. Pin 5. +15. Pin 6. +15. Pin 7. +15. Pin 8, +15. So there's just a bunch of DC on this one. This one, -15, pin 1. +7, pin 2. Pin 3, nothing. Pin 4, -15, supply. Pin 5, 1.2 volts. Pin 6, 1.2. Pin 7, a little bit of noise. Pin 8 should be supply. Yep, okay. So there's no PWM or pulses anywhere around there. PWM and pulses, I don't know where they're really originating from. To tell the truth, 3.1 volts on there, 3.1, -4.9, 0.49, bit of noise, 5 volts. There's pulses there. That's part of the buffers that lead to the output drive ICs. There's a nice square wave. So that is 300 kilohertz. So that is setting the frequency, probably, for the output section. So that's okay, but then the duty cycle is just getting screwed up somewhere. Ah, that doesn't look too good there, does it? That's way down here. Yeah, that doesn't look good at all. Yeah, that looks jank. That is way down here. Have changed this part, by the way, just in case you were wondering. So there's a bunch of traces around here, so I could try changing some of the surface mount capacitors around this circuit, around this area here. Put up the data sheet. What is this? MBAEZ83. MBAEZ83. Don't know what this part is, but let's just try searching this. I think it's one of these. So pin 7 is output B, reference to 5 and 6 in. Alright, I'm going to try hot swapping some of the components from the donor board to this one in this bottom area here, just to see what that does. Got some surface mount caps around here. A couple of transistors here. A couple more surface mount caps over here. One there. Couple of diodes here. Just to see whether that does anything. Just done a KEF PSW 2500 today. That monitor audio, fixed PSU, amps fine. Just goes in the protect with the big rails. FET fine, new op amps caps. Think it's a drive IC. It's so much harder to get parts off of this donor board. I don't know what it is, the solder is different or something. Doing my bloody head in, it is. God damn, these traces are such high thermal mass. What the fuck? Get in a place. Freaking surface mount caps, man. Okay, whether that's done anything or not, let's test it out first, but I think we'll call it there for tonight either way. Give ourselves a bit of a break. Okay, see what that does now. Okay, so it's exactly the same. No change. 102 versus 15. Yeah, exactly the same, no change whatsoever. Okay, well, I think we're going to have to pick it up another night. Yeah, I think we'll lock it off there for this evening. Absolute headache. I can't get a schematic for this, and it's a circuit that I have not really gone this deep into before, so I don't know if it's going to be just a case of working my way backwards through the circuit until, you know, get to the part, whatever it is, the area that's faulty. But yeah, it's really weird how I've swapped out so many parts. I've got a donor board here that technically should have everything on it that works perfectly fine, and I swapped out so many parts between these boards and haven't managed to strike luck yet with whatever part is the problem, which is quite unusual. And I think I have tried like comparing multimeter readings between the boards. Problem is that's quite hard to do now because the donor board is missing lots of parts, so they're gonna read different readings just due to not having parts present on the board elsewhere that would affect the readings. So yeah, really annoying. I just wonder whether the output inductor was like shorted or anything like that was causing it, but no, I don't think so. So yeah, I think we'll pick this up another night, and yeah. Thanks for jumping on the stream, guys. Massive thanks to everyone who shot in donations. Jesse, Matthew, Matthew again with the big boy, Craig, Craig Wharton. I need to remember